Hello everybody, welcome back to my daily coachings, daily teachings, daily tutorials, daily contributions. This is mathematics and it is simultaneous linear equation. And why is it simultaneous linear equation? Because the three equations occur at the same time with the same variable both sides, x, y, and z. This is three variable simultaneous linear equation. So we are going to solve this using any designated method of your choice. We can have about 4 to 5 methods of doing this, but I think I'm going to use the method I think it's going to be easy for everyone. Now firstly, remember this is equation 1, this should be equation 2, and this should be equation 3. Now I'm going to use this equation to reduce this, then I'll also use this to reduce this. We arrive, or we can let me use this one to reduce this and this to form two equations that I can solve with two variables only. Now, having x plus y to be plus z equals to 2 as equation 1, let me make x subject of the formula so that I can find y and z from the beginning. So firstly, we write solution. After that, I take the first equation, which is x plus y plus z equals 2. To make subject x subject, we can see x to be equals to 2 minus y minus z. This should be equation number 4. Now I'm going to use this equation number 4 to reduce equation 2 and equation 3. So from equation 2, we have x. We remove x and put this. So we have 2 bracket 2 minus y minus z, then minus this y minus z again equals to 1. 2 times 2 is 4, 2 times minus y is minus 2y, 2 times minus z is minus 2z, minus y minus z equals to 1. Automatically here we have 4 minus 2y minus y is minus 3y, then minus z again minus 3z, then equals to 1. Now we have minus 3y minus 3z equals to 1. 4 go there, became minus 4. We now have minus 3y minus 3z equals to minus 3. When you divide both sides by minus, everything will be 3y plus 3z equals to 3. In fact, 3 is common to everywhere. It's not only minus, it's going to be minus 3 both sides, minus 3. Minus 3 take away minus 3, minus 3, minus 3 is just 1. So we have y, plus z equals to 1. This should be equation number 5. And I'm going to use it to solve this. So from here, I use this processed equation to reduce this to arrive at y plus z equals to 1. Now let me use this same equation to reduce this by substituting x. We have, in place of x, we put 2 minus y minus z, then plus this 2y, minus 2z equals to 3. Let's solve it. Like y minus y plus 2y is the same thing as y. Then here, remember, we have 2 minus plus y, because I said 2, here 2. Minus y plus 2y is just 1y. We put it here. The minus z minus 2z is minus 3z. Minus 3z equals to 3. Now collect like term by taking 2 towards there. We have y minus 3z equals to 3 minus 2. Then y minus 3z equals to 1. Now this is our equation 6. This is our equation number 6. Now remember, our equation 5 and our equation 2 is two equations with just two variables, which we can easily find. Now let's rearrange them. You know, we have y plus z equals to 1 from equation 5. Then we have that is equation 5. Then we also have y minus 3z equals to another 1. This is equation number 6. Now, since I can use elimination or substitution method again throughout, but here let's make y subject. So we have y equals to 1 minus z. So from equation 6, we remove y and put 1 minus z, minus 3z equals to 1, as you are watching. Now we have 1 minus z minus 3z is minus 4z, remember, equals to 1. Now we have minus 4z equals to 1 minus 1 minus 4z equals to 0. So we divide both sides by minus 4, minus 4 take away minus 4, then automatically we have z to be equals to 0 divided by minus 4 is just 0. That is the value of the z. Now to find y, we use this equation. That is equation number 7. Equation number 7, we use equation 7 to find the y by saying y equals to 1 minus z, and this is 1 minus z is 0, y automatically be equals to 1. So the value of y is 1. Now, if you want to find the value of x when z is 0, y is 1, we use our equation number 4. The equation 4 said x bar equals to 2 minus y minus z. So we have x equals to 2 minus y is 1, z is 0. So x equals to 2 minus 1 is 1 minus 0, then x equals to 1. Automatically, x equals to 1, y equals to 1, and z equals to 0. These are the values of x, y, and z using this method. Now, let me use another method to find the value of x, y, and z. In this time around, I'm not going to clean here. Let me give them as reference as x equals to 1, y equals to 1, z equals to 0. We are going to arrive at the same answer by God's grace. Let me clean this so that we use another method differently. The other method I'm going to use is by using Cremers Rule. Having these equations now, I'm going to form a matrix A that contains this equation. So we have a matrix A to be 3 by 3 matrix, 1, 2, 1. It's going to be 1, 2, 1. The other one is 1 minus 1, 2. 1 minus 1 and 2. Then here is 1 minus 1 minus 2. 1 minus 1 minus 2. Then we now have x, y, z. Then we now have equals to the values. The equalities is 2, 1, 3. Is 2, 1, 3. Now let me find the determinant. I have to find the determinant of this first. The a determinant equals to 1. I don't have to put the 1, the cofactor, all of them are 1, so I don't need to put them. I'll just put the sign in, positive, negative, positive. So the first cofactor is positive. We open bracket and say okay. Or let me see, I'll open a straight bracket showing that it's going to be a determinant, which is minus 1 and 2. Here is a minus 1 and minus 2. Then the next cofactor is negative, so it's going to be minus, open another bracket. Then it's going to be 2, 1, minus 1, minus 2. That is 2, 1, minus 1, minus 2. And the next cofactor is positive, then plus. It's going to be again another bracket. This and this, we have 2, 1, minus 1, and 2. 2, 1, minus 1, and 2. Now let's evaluate this determinant. How do we do it? By saying equals to, in bracket, minus 1 times minus 2 is plus 2. Minus, 2 times minus 1 is minus, okay, 2 times minus 1 is minus 1, minus 2, minus 2 times 1 is plus 2, so here is plus 2 again. Then minus, in bracket, 2 times minus 2 is minus 4, Then, minus 1 times minus 1 is minus 1. There is another minus there, which is going to be plus 1. Now plus again, 2 times 2 is just 4 minus, let me see, 1 times minus 1 is minus 1, and there is another minus there which makes it to be plus, that is plus 1. So this should be 4, minus 4 plus 1 is minus 3 times minus is plus 3. That plus here 4 plus 1 is just 5, and this is the same thing as 12, you know. So the A determinant, that is the matrix, determinant of the matrix is just 12. So we are to find the value of x. How are we going to find the value of x? We remove this part of the x, you know, and substitute it with the 2, 1, and 3. So we are going to form another matrix of x, which is the same thing as, you know, the same thing as 2, 1, 3. Then we have 1, minus 1, and 2. We repeat this and this. There is 1, minus 1, and minus 2. From here, we find the determinant of this. There are so many ways of finding the determinant, but let me just use this same method. But in this case, instead for me to arrange it here, I'm going to evaluate direct to here. So we have determinant, AX determinant to be, the first cofactor is 2, there is 2 bracket. Then minus 1 times minus 2 is plus 2, you know. Then 2 times minus 1 is minus 2, there is another minus there, is just plus 2. So we have this. The next cofactor is negative, which is negative 1, and then you try to just put bracket. Then what next we have is 1 times minus 2 is minus 2. Then 3 times minus 1 is minus 3, and there's another minus there, which is plus 3. Then the next cofactor is going to be positive, that is plus open bracket. So from here, we close here, we have 1 times 2 is just 2. Then 3 times minus 1 is minus 3, and there's minus there, which is plus 3. So the next thing I'm going to have is 2 plus 2 is 4 times 2 is 8. Then minus 2 plus 3, I think, is 1. 1 times minus is just minus 1. Then 2 plus 3 is just 5. Now everything here will be 8 minus 1, I think, is 7. Then 7 plus 5 is 12. 7 plus 5 is 13. 7 plus 5 is 12 again. So we have 12. So automatically here, looking at this, we have our x to be equals to a determinant of x, you know, all over determinant of a. And this is something else. Determinant of x is 12, you know. All over determinant of a is another 12. So we end up having 1. We see x equals to 1. We've started getting x to be equals to 1. Now to find the value of y, in this matrix, we remove this and put this there. That means we can have another matrix of a, y equals to. Now we take 1, 2, 1. Instead of this, we take 2, 1, 3. Then we now repeat this 1, minus 1, and minus 2. You understand? So we are going to find the determinant of this also. To find the determinant of this, we have a, y determinant equals to open bracket. With the first cofactor is 1, we just open bracket, which is positive. Now we close here, 1 times minus 2 is minus 2, you know. Then from here, is it? Yeah, we take this, then we have 3 times minus 1 is minus 3, and there's minus there, which is plus 3. So we have plus 3. From here, then we now see again, we take the next cofactor, which is minus 2 open bracket. We close here, we have 2 times minus 2 is minus 4. Then 1 times minus 1 is minus 1, and there's 1 there, which is plus 1. Then the next cofactor is positive, which is 1 open bracket, and see 2 times 3 is just 6, you know. Minus 1 times 1 is just 1. And this is equals to minus 2 plus 3, I think it's just 1. Then minus 4 plus 1 is minus 3, minus 3 times is just plus 6, you know. Then 5 minus 1 is, I think, is 5. So this is something as 7 plus 55 is just 12 also. So we have the value of y to be equals to a determinant of y all over a determinant. And this is 12 all over 12, and this is equals to 1 again. Remember, our y equals to 1. So from here, we can proceed and get the value of z by forming another matrix of z, which is a subscript z, you know. This is equals to, in this case, our matrix will carry this and this, except this line replaced by this. So we have 1, 2, 1, we have 1, 2, 1, we have 1 minus 1, 2, 1 minus 1 and 2. Then here, instead of this, we take this 2, 1 and 3, 2, 1 and 3. Now we have matrix of z. Now let's find the determinant of this matrix. the determinant of this matrix is AZ, you know, determinant, and this is equals to, the first cofactor is 1, we put that is plus 1, then we close using minus 1 times 3 is minus 3, then 2 times 1 is minus 2 again. From here, we're gonna take the next cofactor, which is a negative, and open bracket, we say 2 times 3 is 6, you know, then minus 1 times 1, which is just 1, minus 1 times 1 is just 1, we put minus 1, then we now see the next cofactor is positive, we say plus, and it has 2 out, so we have 2, we have 2 times 3 is 6, you know, then 2 times 3 is 6, is it 6? No, 2 times 2 is 4, because I take this, I'll block here and here, we consider only this, so we have 2 times 2 is just 4, then 1 times minus 1 is minus 1, and there's minus there, which is just plus 1, so this should be the same thing as minus 3 minus 2 is minus 5, then 6 minus 1 is 5, 5 times minus is minus 5 again, then 1 plus 4 is 5 times 2 is 10. Remember, this is equals to minus 5 is minus 10 plus 10 equals to 0. Automatically, my z equals to a z determinant all over a determinant, and this is 0 all over 12, and finally equal to 0. That's why I said x equals to 1, y equals to 1, z equals to 0. Remember, from here, x equals to 1, you know, then y equals to 1 and z equal to 0. Not only this method, there are plenty methods used in solving this problem, but this is what I can afford for you now. 2 methods are okay. Thank you and have a nice day.